Good morning, class. Please all stand up. Anyone who wants to lead a prayer? Amen. Before taking your seat, kindly pick up some pieces of papers and arrange your chairs. Once again, good morning. How are you today? That's good to hear. Is there any absent for today? None? Very good. Now, I will going to say the rules, so please listen. Number 1, everybody must participate with our lesson. Number 2, if you have any idea or questions, just raise your hand. And last is, respect is a must. Let's have a recap of what was our lesson is all about last meeting. Who among you here still remember our lesson last meeting? Yes, it's all about finite and infinite sets. What are the difference between the finite and infinite set? Very good. Thank you for sharing your idea. Now, let's move on to our new topic. But before anything else, let us have a game called Missing You. The instruction is fill in the blank to complete the words. Are you ready? Number 1 is kindly write your answer in a 1/4 sheet of paper and just take a photo of that answer. Is that clear? Alright. Number 2. Number 3. Number 4. And the last one is okay. Now let's have an activity. I will group you into 3 and this activity is called Where Do I Belong? The instruction is put the words to its meaning. Put the words to its meaning. I have a paper here that has a word written on it. For the purpose of this paper, simply place it in the blank that you believe it contains the answer of that question. I'll just give you 3 minutes to finish that one. Are you done? Okay, since we are done with our activity, let us try to reflect these following questions. So, number 1 is, what is the main focus of the Continuum Hypothesis? And the second is, what are the difference between finite and infinite set? Now, do you have any idea what will be our topic for today? Yes, James? Yes, it's all about Continuum Hypothesis. Before we proceed to our topic, let's read the objective first. So at the end of the lesson, the student should be able to define and discuss the Continuum Hypothesis. Second is create a concept map of the Continuum Hypothesis and develop cooperation throughout the discussion and activities of the Continuum Hypothesis.
Based on the questions you have answered, what have you observed with the concept of continuum hypothesis? May I call a student from the class? Thank you, Miss Ara. Now, let's proceed to our discussion. Are you now ready? That's good. Continuum hypothesis is a statement of set theory that the set of real numbers is in a sense as small as it can be. In 1873, the German mathematician Georg Cantor proved that the continuum is uncountable. That is, the real numbers are a larger infinity than the counting numbers, a key result in starting set theory as a mathematical subject. Furthermore, Cantor developed a way of classifying the size of infinite sets according to the number of its elements, or its cardinality. In these terms, the continuum hypothesis can be stated as follows. The cardinality of the continuum is the smallest uncountable cardinal number. The continuum hypothesis asserts that there is no set intermediate in cardinality between the set of real numbers and the set of natural numbers. Since the continuum can be shown to have the same cardinality as the power set, that is the set of subsets of the natural numbers, continuum is a special case of the generalized continuum hypothesis, or the GCH, which says that for any infinite set, there is no set intermediate in cardinality between it and its power set. Cantor first proposed continuum hypothesis believing it to be true, but despite persistent efforts, failed to prove it. Koenig proved that the cardinality of the continuum cannot be the sum of the innumerably many smaller cardinals, and it has been shown that this is the only restriction the accepted axioms of set theory place on its cardinality. Gödel showed that continuum hypothesis was consistent with these axioms and Cohen that its negation was. Together, these results prove the independence of continuum hypothesis from the accepted axioms. Cantor proposed continuum hypothesis in the context of seeking to answer the question, what is the identifying nature of continuity? These independence results show that whatever else has been gained from the introduction of transfinite set theory, including greater insight into the import of continuum hypothesis, it has not provided a basis for finally answering this question. This remains the case even when the axioms are supplemented in various plausible ways. Do you have any clarification about the discussion? If that's the case, then let's proceed to another activity. Are you all excited? That's good. This game is called Identify Me. Instructions. Answer the following questions based on the information provided about the continuum hypothesis and its independence from set theory axioms. Okay guys, this is for test 1. Direction. Encircle the correct answer. For test 2, create a concept map about the definition of continuum hypothesis. Make it in a creative way. It is equivalent to 10 points. Are you done? Alright. The continuum hypothesis in set theory, introduced by George Cantor in 1873, posits that the set of real numbers is as small as it can be, specifically having the smallest uncountable cardinality. Cantor's proof that the continuum is uncountable marked a pivotal moment in the emergence of set theory as a mathematical subject. His work also led to the development of cardinality, a system for classifying the size of infinite sets based on their elements. Continuum hypothesis asserts that there is no set with cardinality between the continuum and the set of natural numbers. Remarkably, it is a special case of the generalized continuum hypothesis, which extends this idea to any infinite set, stating that there is no set intermediate in cardinality between a set and its power set. Cantor, despite proposing continuum hypothesis with conviction, faced challenges in proving it. Koenig later demonstrated that the cardinality of the continuum hypothesis cannot be expressed as the sum of the innumerably many smaller cardinals, presenting a crucial restriction imposed by set theory axioms. Gödel's contribution confirmed that continuum hypothesis is consistent with set theory axioms, while Cohen demonstrated that its negation is also consistent. Together, these results prove that the independence of continuum hypothesis from the accepted axioms, adding complexity to the understanding of this hypothesis. Cantor's motivation for proposing continuum hypothesis was rooted in the quest to uncover the identifying nature of continuity. Despite the introduction of transfinite set theory and the insights gained from continuum hypothesis, a definitive answer to this fundamental question remains elusive. Even when set theory axioms are supplemented in various plausible ways, the question of continuity's identifying nature persists, highlighting the enduring mystery surrounding this concept in the realm of mathematics. Okay, that will be the end of our discussion. Goodbye, class. Goodbye.